most discussions of AI overlook one key distinction that changes how these systems actually work.
The language we get from models like ChatGPT and Gemini is getting incredibly sophisticated. Their ability to write coherent, well-structured sentences is improving at a startling pace.
And this creates a huge misunderstanding, because while the words sound more correct, the system's ability to know if those words are true isn't improving nearly as fast. That gap is where the problems begin. This isn't just some small mistake. It's a real-world case where an AI confidently made up completely fake court decisions, complete with fake case numbers and fake legal arguments. The output was plausible, it was detailed, and it was entirely false. This phenomenon has a name. It's called a hallucination. And it's not some random bug or a glitch in the system. It's actually a core part of how these things are designed. So why does it happen? Well, to really understand why, a story from the early 1900s gives us a surprisingly clear answer. The question back then was the same one people are asking now, only it was about an animal that had everyone completely captivated. So there was this horse, Clever Hans. You could ask him a math problem, and he would tap his hoof the correct number of times. Ask him what's 4 plus 2, and he'd tap 6 times.
And to everyone watching, it seemed undeniable. The horse was actually counting, adding, and subtracting. It really looked like genuine intelligence.
Of course, people were skeptical, and that led to an official investigation by a psychologist named Oscar Pfungst. He set up a bunch of tests to figure out what was really going on. Pfungst quickly discovered that the horse couldn't get the right answer if the person asking the question didn't know the answer themselves. He also couldn't answer if he couldn't see the questioner. It turned out Hans wasn't doing any math in his head at all. What he was actually doing was watching the person asking the question. He was reacting to tiny involuntary changes in their body language, a subtle shift in posture, a slight tilt of the head that unconsciously signaled when he should stop tapping.
And here's the key takeaway. Hans was an expert at pattern recognition, not math. He had figured out a brilliant trick. Just give people the response they are subconsciously signaling for.
And that story brilliantly illustrates the core way a large language model actually works. A lot like Clever Hans, language models are designed to recognize patterns in our language, not to understand or check for truth. They are masters of statistical performance, not knowledge. These models work on a purely statistical level. They look at a sequence of words and then calculate which word is most likely to come next based on the immense patterns of human writing they were trained on. And this process leads to text that sounds fluent, correct, and even authoritative, because it perfectly matches the patterns of how humans write when we share factual information. It's built to create something that just looks right. This is a classic example. You ask an AI for the capital of Australia, and it might tell you Sydney. That sounds right to a lot of people, but it's wrong. The capital is Canberra. It picks Sydney because in its vast training data, the word Sydney is just statistically more associated with Australia and capital than Canberra is. It gives you the most probable answer, not the factual one. This creates a serious challenge for anyone using these tools, a problem that's becoming known as the AI trust paradox. Here's the paradox. As these models get more fluent and sound more human in the way they write, their answers naturally seem more trustworthy to us. You could also call it the verisimilitude paradox. The simple appearance of truth makes us want to trust it, even when we shouldn't. We're just naturally wired to believe a confident, detailed answer. Now, here's the really counterintuitive part. Research suggests there's something called a rebound effect. The more capable a model gets with language, the more credible, and therefore the more risky its fabrications become. We instinctively connect fluency and specificity with expertise. So an AI's ability to generate dates, names, and technical-sounding details just makes its hallucinations even harder to spot. And even as these models get more and more sophisticated, their core function hasn't changed. It is still a system predicting the next plausible word based on the statistical patterns it learned from its training data. So the system's impressive performance isn't a reflection of its knowledge about the real world. It's a reflection of the patterns in its data. Just like Clever Hans, the intelligence we perceive is an illusion, one created by an amazing ability to give us the answer it predicts we want to see.